Hello and welcome again to another edition of Lost in Science. This is half an hour on the radio or some other form of listening device where we talk about science. Who are we? Well, I'm Stu, and on the show this week I'm going to be talking about a new threat to all of humanity called... well, it's not really. It possibly is. There's basically a new kind of insect pest, and they don't really know how they're going to keep that under control. And I'll explain how there can possibly be a brand new species of insect pest later on in the show.
Is it Mothra?
It is related to a Mothra. Yeah.
Really?
Yeah.
Is that as tall as a building?
No. They're actually quite small, but very
to
voracious and unstoppable in other ways. Claire, what have you got for us?
Well, speaking of voracious and unstoppable insects, I'm actually talking about fruit fly who like to hang out in red light districts today. This isn't a joke. It's actually about fruit fly sex, and
red lights.
And red lights. So we will go into some new research that has just come out. That proves that fruit fly like to get themselves off.
I want to know what you Googled to find this.
Claire's in the fruit fly vice squad.
Yeah,
we will take that offline, Chris.
Okay, check your search history.
Sure.
Oh, well, as for me, my name's Chris, and I love like to sort the science from the fiction in the health studies and this kind of stuff. I like to bore you all with these sort of accurate science. And one thing we talked about before is research about whether certain foods are good or bad for you. Today, I thought I would tackle the big three: alcohol, coffee, and chocolate. What does the real science actually say about their net effect on your health? I have some good and some bad news. So, yeah.
I love good and bad news.
Yes. Yeah,
Are we going to get the bad news first or the good news?
You should wait and see.
Well, please do wait and see, and stay tuned for the rest of the show. One of the most expensive parts of food production is pest and disease control. Basically because without taking action to protect food growing on farms, other animals and microbes will eat it first, so we would not get any food. So the global agriculture industry trades over $1 trillion worth of produce every year, and 80% of that is food. The other crops being fibre and oil crops, basically. So most of the pests and diseases that farmers have to treat are well understood and widely studied, and we've got reasonably effective control measures available for use. So farmers in more developed countries have greater economic access to chemical controls, but even they are actually really cheap. So some of the most commonly used insecticides, for example, only cost a couple of dollars per hectare to treat for insects. But it is very unusual for a new pest to appear. So most of the problem insects have been around since farming began thousands of years ago. And though they have been spread round through trade and importation of contaminated goods and various failures of quarantine, pests do move from country to country, they're also pretty stable. So the species of insect that we have now that are pest insects have been around for a really long time. Some insects have developed resistance to particular insecticides over time through overuse of insecticides or incorrect application rates, but they're basically still the same species that have always existed until now.
Dun, dun, dun.
So there's a particular pest insect from Europe known as the Old World bollworm, and it's gotten friendly with a species of insect from the Americas known as the corn earworm, and they have reproduced.
The exotic cousin came to stay for a little while.
Yeah.
I thought earworms were just songs that got stuck in your head.
Well, it's a corn earworm, so yeah. So the two species are in a genus of moths called Helicoverpa, and the European species H. armigera found its way to Brazil. probably sometime back in 2008, they estimate.
So hang on, what are they the same genus or the?
They're the same genus, but they're
Okay.
different species. And it interbred with the local Brazilian species called Helicoverpa zea, which actually is the same name as the
Zea
maize.
mace.
Yeah, the maize plant.
Corn plant.
So, because of this hybridization between the two species, there's a concern that the new hybrid worm, which is really a kind of caterpillar because it's a baby moth, may be resistant to commonly used pesticides to treat the two parent species. So Dr. Tom Walsh from the CSIRO was part of a team who published research mapping the genome of the new hybrid moths and has indicated that several individual strains of hybrids seem to exist, and in fact, no two hybrids that they had access to had the same genome. So basically, they're hybridizing all over the place and recombining those genes
Oh wow!
really rapidly all throughout Brazil. So basically, yeah, so there's several individual strains of the hybrid. They're also aggressive and cannibalistic. So basically they will eat each other, but that just results in really big, giant, fat caterpillars that have eaten all of their competition. So they're not very nice caterpillars either. But it also means that hybridization happened more than once and is probably still happening and will keep happening, potentially giving rise to a number of local ecotypes that could spread out through Brazil and into other areas. And the hybrids have been spotted in various other countries in South America and also 3 times in Florida. So they've actually hit the mainland US as well.
Is there any instance of the Brazilian moth in Europe?
No, this is the first time they've sort of come into contact with each other. So obviously this will possibly be devastating for the cotton and corn growers in the Americas because both of these species named, the bollworm is because it eats cotton bolls and the earworm because it eats corn.
Oh my goodness.
But the moths are not restricted to those crops and actually feed on over 200 different crop plants, including soybeans, which is a huge food product, chickpeas and tomatoes, just for some familiar plants that we will probably all miss if they get eaten by.
That's a very wide range. Like, those are completely different kind of plants.
They
Aren't they?
they can basically eat anything.
Including each other.
They eat each other. They eat all sorts of different crops. They have no plants seem to have a specific defense against them.
It does sound like a science fiction movie.
It kind of does. So there's no immediate threat to Australian farms. So the authors of the paper in the Proceedings of the National Academy of Sciences of the USA have warned that global trade means global pests. And what they're saying is that because we trade these commodities all around the world, it's very, very easy for an egg to make its way from one country to another. So if these, we actually in Australia already have the old world bollworm, and we treat it currently using a range of chemicals, but it's already resistant to a number of insecticides that we use. So if the corn earworm gets here from the Americas, then it could hybridize and cause the whole problem again. So the risk of new hybrids appearing here could potentially cause the cost of farming to go up and cause the number of or the rate of crop losses as a result of the insect pests to go up, and will probably mean that the cost of food will go up, not just in Australia but all around the world, because there'll be competition and market forces basically mean the price of food will go up. So that's what happens when little insects get together out of their natural range and habitat.
You're traveling through another dimension. A dimension not only of sight and sound, but of mind. A journey into a wondrous land whose boundaries are that of imagination. That's the signpost up ahead. Your next stop.
Lost in Science.
So, a warning, everyone. I will be talking about fruit fly sex in this segment, specifically fruit flies in red light districts. So, if you aren't comfortable with talk about insect copulation, tune out for the next 8 minutes. But for everybody else here, everyone will be happy to know there's been an important discovery made by researchers this week. Male fruit flies ejaculate, and scientists can make them do it.
Did they not know this before?
No, they didn't know this before.
Okay.
And they have.
They've been watching
No.
fruit flies
Okay,
breed
so they
for
knew they
ages.
ejaculated, but
Okay.
they didn't know how
to
to do it, and
Right.
they didn't know they have a very enjoyable time doing it.
The scientists or the flies?
Well, presumably both, but I'm talking specifically about the flies here.
Okay.
So there's been a newly published study by Galet Sholat Ophir from Bar Ilan University in Israel, and it is pretty remarkable. So what the researchers wanted to look at was what is the evolutionary driver for a species to reproduce? Because as we all know, reproducing is it's very important, and to sexually reproduce, an animal must engage in sex. But what is driving this sexual activity? Is it something to do with the coupling of a female and a male, or is it simply the pleasure in the ejaculation itself?
Come on, Claire, tell us about the birds and the bees. Well, it's not the birds and the bees, is it?
No, it is
it's the flies
it
and
is
the fleas.
it's the flies.
Well, the educated fleas do it. We know that much.
Anyway, so the researchers asked the question for the fruit flies. Is making a fruit fly release sperm in the absence of a female partner enough to give the fruit fly the perception of a reward? So, is the fruit fly doing it by itself the same as a fruit fly doing it with a female?
Okay.
And it turns out yes. That is, fruit fly as well as humans find orgasm pleasurable, which is quite interesting. And it doesn't matter if they're doing it together or they're doing it alone. So this study really shows that there is an association between pleasure and sex, and it dates way back in evolutionary time than what we thought.
How do we know it was pleasurable?
Well, that is a great question, Chris. They had a very, very cool research method. So to do this experiment, they genetically engineered a fruit fly so they could control its production of something called corazonin. And this corazonin is a protein that prompts ejaculation. And the way that they controlled it was using red light. So pretty much you flash a red light at a fly and that fly ejaculates. That's what scientists did.
So they genetically modified the flies so that when they flashed a red light at them, they ejaculated.
Yeah.
That's some pretty weird research proposals going in right there.
Considering everything else that scientists have done to fruit flies over the years, I don't think it's that weird. I think it's actually sort of nice for the fruit flies. And anyway, let's... Chris is looking so stumped over there. Anyway, okay, so that's the first thing. They genetically engineered this fly, so when there was a red light, it would ejaculate. Next, they created a special enclosure for the male flies with one side red lit and the other side not. Then using so normally corazonin making neurons, so this sort of ejaculating making neurons, they only fire after there's been this really complicated courtship ritual and involves chasing and stroking and singing and
Singing?
Singing, fruit fly singing, and eventually mating. But obviously they dispensed with all of that when they genetically modified them and just went straight for the red light. And why red, I hear you ask? Is it just a great gag? Yes, it is a great gag, but also red light passes through living tissues quite easily. So even an overhead lamp can trigger neurons deeply embedded within the fruit fly. Also, fruit flies can't see in red, so it takes out it's clear that they can't actually see anything.
Hey, whoa, so they're reacting to a light they can't even see.
Yeah.
Okay, now my mind is blown. I thought they were like seeing a red light and going, oh, that's pretty amazing. But the red light is actually directly interacting with their brain. Is that
Yes.
what's happening? Wow. Okay. That is
Yeah.
even more weird.
Yeah. The red light is directly going into their brain.
Right.
Yeah. Yeah. They put them in this little box, half red light, half not, and before long, they found that these genetically engineered male fruit fly, when they were given a choice, they all preferred to hang out in the red light. In effect, they were getting themselves off.
And so they must have been going for the red light because of how it made them feel, because they couldn't see the red light. Otherwise, this experiment wouldn't work, because they might just go, I just like the red light. It's
Just
fine.
like the red light.
But no, they can't even see it, so they don't even know that it's red light.
What's super weird as well is they then associated the light with a smell. So they had one smell where the red light was, and they had another smell where the red light wasn't. And then they turned the red light off, so they were no longer getting that reaction.
Mm-hmm.
And
They went for the smelly
They
part.
still went for the smelly part. So they associated the smelly part with this like pleasure, and they're like, searching for it.
Did they still get their rocks off at the smelly bits?
No, they didn't get their rocks off at the smelly bits. Or did they? I don't think they did, but I should read that again. And the other really interesting part is when flies are more likely. Yeah, so when they're in this red light, they're actually less likely to consume alcohol. This may seem a little bit weird, but earlier studies have shown that that sex-deprived fruit flies are actually more likely to drink alcohol.
So they're often attracted to like rotting fruit and
Yeah.
things like that as their natural food source. So that's not a huge leap to think that they would just, not having any sex, so I might as well go and get drunk.
Yeah, but when they are getting the pleasure from the red light, getting their rocks off, they're less likely to drink alcohol. It's all very weird. I love it. Anyway, so there are some very interesting results here around hormone, brain function. Scientists being able to control fruit fly to this extent, and also possible future research looking at neurological pathways and the drivers keeping us safe and happy and leading us to addiction, possibly.
I can't help noticing, though, that it is male fruit flies. They're just focusing on the male kind of enjoyment.
Well, I noticed that as well. And, obviously her team only has half the picture here. They're only studying male fruit flies. This is... I think a lot of people are noticing this, especially because most of the literature out there and the understanding, there isn't a lot of understanding around female sexuality and pleasure. It's always lagged significantly behind that of male. But the researchers have made some preliminary results about female fruit fly sexuality and pleasure, and we'll be releasing them soon. So I'm looking forward to hearing how female fruit flies as well get their buzz off.
Across Australia on the Community Radio Network, you're listening to Lost in Science.
Yes, you are listening to Lost in Science. My name is Chris, and we're tackling the big three of booze, Java,
Chocolate.
and Jockey Num Nums. Chocolate, yeah.
Is that the scientific name?
Scientific name. Now, there seems to be constant news on these topics. You always hear these studies going... a new study says that this week chocolate is good for you, next week chocolate is bad for you, this kind of stuff. But we all know that one individual study doesn't tell you everything. You need to look at the balance of the research, and that's what we like to do here at Lost in Science. We like to really work out what the real picture is, don't we?
We like to get unlost.
We'd like to get unlost. So the results may or may not surprise you. We shall see. Let's start with alcohol. Good or bad, folks?
Bad.
I'm going to go with bad, but, you hear a lot about red wine being possibly good, antioxidants, blah, blah, blah. That's what I'm telling myself on a Friday night. Blah, blah,
Okay.
blah.
That's good, and we will have a look at that. Well, the answer is Stuart's right. Is bad. Now, but you're
What
right. We
about
have been told that moderate drinking is good for us. It's good for your heart, they say. In particular, red wine, people try to suggest that. But generally, the alcohol industry seems to kind of ride in this kind of health halo that, moderate drinking is okay and drink responsibly, this kind of stuff.
Oh, yeah. I mean, it's great for them, isn't it?
Yeah. Now, this seems to have kind of really started with the so-called French paradox, which was an observation from the late 1980s that the French seem to have a low rate of coronary heart disease, which includes heart attacks. And this is despite them eating lots of cheese and butter and drinking lots of red wine. Now, there is still a lot of controversy about whether the French paradox was a real thing or not and what the reason for it was, but it is particularly one kind of cardiovascular disease that they were looking at there, and there's a lot of other things like,
strokes and heart failure and this sort of stuff, not to mention cancer, and alcohol is associated with cancer. Now, recently there was a big study published in The Lancet, this is in April this year, that gave a clearer picture. When I say a big study, this study had like over 100 authors. It involved 599,912 people in 19 countries. So it was a huge study, and they found there was a clear increase in the risk of death for alcohol consumption starting at about 100 grams of alcohol per week. So in Australian terms, it's like standard drink in Australia has 10 grams of alcohol in it. So this is 10 standard drinks per week is where you start to see the danger from alcohol consumption go up. Now, our current guidelines in this country say no more than 2 standard drinks in any day, which is potentially 14 standard drinks per week. So we're still a bit above what this research is saying. Now, if you look at just at the cardiovascular disease, there is a reduction at about this 100 gram level, and that is due to a drop in non-fatal heart attacks. But we're interested in the things that actually kill you, and for the graph for deaths, there is a clear upward curve starting at about 100 grams per week. With the red wine thing, yeah, look, it did look into that. People talk about a chemical called resveratrol in red wine. Look, it's maybe not enough of it in the wine to be helpful. Also, the results, studies looking at that shows maybe not as good as it might have thought. But anyway, this is like these big studies that don't kind of discriminate the kinds of alcohol show that, yeah, alcohol basically is harmful for you. There are some kind of complications here. This research, like, obviously relies on people accurately calling and reporting what they drink. It also only looks at the current drinking, not what people have made drinking years ago when they might have done more damage. But still, alcohol seems to be not much of a benefit from moderate drinking. And yeah, keep below 10 standard drinks per week. Unfortunately, that was the bad news that I had for you, I'm afraid.
All right, thanks, Dr.
Oh, well,
Chris.
okay, good news then.
Yeah.
What's the good
Time for the
news?
good
Okay,
news.
maybe I'll spoilers. Coffee, good or bad, folks?
Oh, well, I think good.
Look,
I wouldn't be able to
am
operate without it.
I'm an optimist. Good.
Okay. Well, you're right. Good. I mean, as long as you're not pregnant. Now, this may be...
Really?
Yeah. This may be surprising because coffee doesn't seem like it should be good for you. Like, it makes you jittery. It feels addictive, which we associate that with being bad for you. But there have been a number of recent large studies, a few large studies came out last year that showed benefits from drinking coffee. And again, when we're focusing on the thing of all-cause mortality, which is like all the total relation to total deaths, and things that you might have thought would be affected by it, such as heart arrhythmia, things like atrial fibrillation, where the heart beats kind of out of rhythm really fast. That turns out to actually be improved by caffeine. It's possibly due to opening up blood vessels and increasing blood flow. But yeah, it's a surprising result because you would have thought coffee would be bad for your heart, perhaps. And there are some provisos here. I mean, there may be possible carcinogenic chemicals in coffee. There was actually a recent court case in the United States where a judge ruled that Starbucks should have a warning on their coffee about a particular chemical introduced in the roasting process,
Or that their coffee's just not very good.
Yeah,
Should
yeah,
also
but this
be a
was
warning.
that was a legal judgment, not a scientific one, really. And again, it doesn't show up when you look at all-cause mortality, all deaths. The difference is obviously, pregnancy. There's a few complications when you look at pregnancy. So higher coffee consumption associated with a greater risk of low birth weight, loss of pregnancy, preterm birth, and childhood leukemia from coffee consumption in pregnancy.
How much coffee consumption are we talking about? Because you don't want to freak people out here.
During pregnancy, well, I say try not to drink coffee when you're pregnant. That's kind of the advice.
Really?
Yeah.
Okay.
Yeah. But look, as for other people, about 300 milligrams of coffee per day, which is about 3 to 4 cups of coffee. 300 milligrams of caffeine, which is about 3 to 4 cups of coffee per day, seems safe and beneficial for you. Like the benefits aren't necessarily huge, so no one's saying at this point that if you don't drink coffee, you should start, but there's certainly no reason to stop. Obviously, don't drink too late, otherwise you keep yourself awake at night, and that's bad for you as well. But still, yeah, like 3 to 4 cups of coffee, not a bad recommendation. Yeah. So anyway, chocolate. Let's go to the next one. Chocolate, good or bad?
I'm going in with good.
I'd say good, but with some pretty major caveats on that.
Yeah, look, I had a look at this one. It's mostly good, but it's a bit unclear. We have to go with the jury's still out on this one, I'm afraid. There is very good reason to believe that it is good for cardiovascular disease. Been a number of studies showing that. But it does also contain fat and sugar, as well as many other chemicals that could all do all sorts of things. If we want to look at the big picture, we try to look at this, all-cause mortality, whether it will kill you or stop you dying. I found 2 prominent studies that address this. There was one in 2006 of elderly men that did find a big reduction in deaths, both from cardiovascular disease and total number of deaths. But there was another study from Sweden in 2009. This was on patients who already had a heart attack, but it found no significant effect on deaths overall for chocolate consumption. There was an effect on, deaths from cardiac disease, but nothing to do from overall deaths was not reduced. But these kind of studies also focus on dark chocolate, obviously, because it minimise the bad stuff in the chocolate. They also use, when you read them, they use small quantities, typically around about 10 grams per day. There was one recent review that I read that had recommended less than or equal to 6 30-gram servings per week, which is 180 grams per week.
It's really not even a chocolate bar.
No.
So
no.
It seems a little bit low.
So this seems to suggest that if chocolate is good for you, it's probably likely to have a fairly small effect. It's not a very strong, not a very powerful medicine. And you're probably going to get better results by eating vegetables. But no one wants to hear that, really.
What about chocolate-coated vegetables?
Maybe that could work. But yeah, certainly there are some beneficial effects, and a moderate consumption, assuming moderate for you, is like maybe a block per week.
That's all we've got time for on this episode of Lost in Science. Thanks for tuning in and joining us. Lost in Science is recorded at the studios of 3CR in Melbourne and broadcast across Australia on the Community Radio Network with the financial assistance of the Community Broadcasting Foundation. If you want to talk back to us, you can get in touch. We have a Gmail account, lostinsci@gmail. You can also find us on Twitter and on the Facebook. And if that's not enough Lost in Science for you, you can always tune in again next week, where the team will once again get Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.